Hi class, so in this video I'm going to talk about the measurement lab that we did. The main purpose of doing this measurement lab was to have you be familiar with some of the tools that we use in a classroom to be able to do measurements, but also how that relates to significant figures, which was one of the early quizzes that many of you took. So the first thing was we looked at several different measuring devices. We used some of these in this lab, and other ones we've used throughout this class or we will be using very soon. So just wanted to make sure to go over those. This one in the top left-hand corner, these are called pipettes. That's a P. Pipettes. And sometimes they have gradations on the side which allow you to do measurements as well, not just suck up a liquid and then to transfer it into another container. The second one here is a graduated cylinder. And graduated cylinders are used to measure large amounts of liquid. There are other ways to measure very small amounts that are much more accurate than graduated cylinders, but for our purposes right now, our graduated cylinder helps us measure volumes in the scale that the graduated cylinder requires. Like this graduated cylinder shown has 100 milliliter maximum, and you can't really measure anything below 5 because it doesn't have any lines, right? Have lines really below that 5 milliliter line. This is an electronic scale. Electronic scales allow us to weigh masses, where so far in these 4 images on the left we're measuring volumes. And so we used that to measure grams, but obviously we can use it to measure other units of mass measurements. On the left bottom here is a beaker, and even though it has lines on it, these lines are only suggestions. They're kind of ballpark measurements, so you would never use a beaker or the next one that we're going to talk about as a way to measure exact volumes. The lines here are just suggestions again, but a beaker is a good way to hold a large amount of liquid. This is called an Erlenmeyer flask. We use Erlenmeyer flasks sometimes instead of beakers because it allows us to mix without spilling. You can also put a stopper in the top of the flask, so you can contain a liquid, or you can put a stopper with a hole in it to be able to transfer liquids or gases from the flask to something else once it's being produced in a chemical reaction. So again, you can see there's very few lines on here, so these are just suggestions. Erlenmeyer flask is really just for mixing and for transferring liquids from one container to another, or a gas using a stopper. So in this lab, one of the primary purposes was to have you learn how to use a graduated cylinder. So first, you have to put your eyeball at the level of the liquid, and you're looking for this curve, right? This curve is called the meniscus, and you see it's right there, right where it curves down. The liquid attaches itself to the side of the container, since most of the things that we use in class are water based. The liquids are water-based, or the solutions are water-based. They're dissolved in water. They have an attraction, a adhesion to the surface of the container, either plastic or glass. And so that causes it to curve up on the sides. So you don't measure on the sides, not there, right? Right there in the center is where you measure. Now it helps to put a white piece of paper behind it. So the first thing you would do is maybe put a white piece of paper behind the graduated cylinder. Then you put your eye, get down at eye level with the meniscus, and then you would read the meniscus. So the most common mistake is people would measure on the outside of the liquid, where the liquid is touching the side of the container, and not where it's coming down in the middle of the graduated cylinder. So in this case, you see that the liquid is sitting right at the 67 line. one thing you have to do is you have to make sure you know what each of these little lines means, right? These minor ticks. And so you see there's a major scale division at 60 and at 70, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9 lines. So that means there's 9 lines, which means there's 10 spaces in between the 60 and 70. That means each of these lines is 1 milliliter. So you count backwards here, 69, 68, 67. It's sitting right on the 67 line. So you would write 67, but then you have to guess an extra digit, right? If you're exactly on the 67 line, you would write 67.0, and then you would write the units. Remember, units are very important because they give meaning to the number. So the answer here would be 67.0 milliliters. So in this example, you see that there are major scale divisions at 6 milliliters and at 7 milliliters, and you see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 lines in between 6 and 7. So that means that each of these lines is, these little lines, these minor scale divisions, are 0.1. So you see it's above the 7 line, so it's 7.1 milliliters, but then you have to guess in between the lines and see that's a little, the meniscus is a little bit above 7.1. So maybe we say 7.13 milliliters. So this gets at significant figures. What numbers actually have meaning in a measurement? Significant figures actually comes from measurement. So it's the number of certain digits. The certain digits come from the lines on a measuring device. And the uncertain digits, and you always guess one uncertain digit, and that gives you the number of significant figures. So in this example that we just did, the 7 and the 1 are the certain, and the 3 is the uncertain, and that gives us the number of significant figures, which is 3 significant figures. But remember, when you're counting, it's an unlimited number of significant figures. So that means that if you're counting a graduated cylinder, so there's 1 graduated cylinder in this image, it's actually not a measurement. It is counting, so that would be an unlimited number of significant figures, or infinite. When you're using an electronic scale, the values on here actually tell you how many significant figures there are. So on your electronic scale, if you got 3.42 grams, you will notice that when you're weighing, this number is the last one to stop moving. So that's actually the uncertain digit. And the 3 and the 4 are the certain digits. So in this case, it would be 3 significant figures for the electronic scale measurement shown here. So I hope that was useful in review of the measurement lab. Thanks. Have a nice day.